Okay, so today we're learning about how to factor quadratic trinomials where the lead coefficient isn't 1. Then when I'm talking about the lead coefficient, I'm talking about the squared term. It doesn't automatically have to be the first term, but whatever the squared term is, the lead coefficient is not 1, then this is the type of quadratic trinomial we're learning to factor. You always want to look to see if you can factor out a greatest common factor first. There's not one here, so we're going to have to deal with this as is. So, first thing we want to consider is that the way we would generate the 2b squared, there's really only one way we can do that. That's going to be the f of FOIL multiplying our first 2b times b, and that would get us 2b squared. Now, because the lead coefficient is not 1 now, we can no longer say the factors of 15 that sum to 13. That won't work anymore. So one of the ways we can factor these is kind of just do it by inspection or educated guess, but we can really narrow down the possibilities. One thing we know is that since all the terms are positive, the only way to generate a positive middle term and a positive third term is if the terms that we're factoring, the terms of the binomials that will be the factors of the quadratic trinomial, those will all have to be separated by an addition sign. There's no way for subtraction to be involved there. So I have 2b plus. Now I need factors of 15 that are going to work here. I could put in the possibilities. I could put in, for example, I could put in 15. Let me use different colors to get a little more contrast. I could put in, when I say where am I putting things into, I'm putting things in right here and right here. So when I'm writing over here, that's what I mean. So when I think about what I could put in there, I could put the 1 in the term with the 2b, put a 1 right there, and a 15. Those would be factors of 15. Again, not that sum to 13, but just that would work here, and we'll talk about what work means in a second. I could also have 15 and 1. My other factors of 15 are 3 and 5 and 5 and 3. So what's going to work? One thing you would want to note is that this is very unlikely to be a possibility right here because if I was to put a 15 right here, I would have 2b times in my outers of FOIL. I would be up at 30b, and that already would be above 13b, so that can't be it. I also really couldn't have a 15 even right here, because I would have 2b squared plus 2b. I would have 2b squared plus 2b plus 15b, and I would have surpassed 13b in my O and I of FOIL. So let's eliminate those as well. So that leaves me really with these two possibilities, 3 and 5 and 5 and 3. And where I place them matters because it's going to generate, because one of them is going to get multiplied by the 2 and the other is just going to get multiplied by b. So placement will matter. So let's play around a little bit here. What if I put in the 3 there and the 5 there? Well, I would have 2b times b, that's 2b squared, plus the outers would be plus 10b plus 3b, and that's actually going to be it. So that's going to be our factoring, 2b plus 3 times the quantity b plus 5. If I tried the 5 here, and when I say 5, I mean in there, and I tried the 3 here, I would not get what I start with here. So it would be 2b times 3, which would be 6. It would be 2b times 3, which would be 6b. Well, let's do it in order. 2b squared plus 6b plus 5b, so that would be 11b. That would not be 13b. So that isn't a possibility. So this is our answer. Let's go with that for that one. That's the correct factoring. All right, so let's look at this next one of 3a squared minus 4a minus 4. So now this one's a little bit different in that, well, I know that I can generate the 3a squared by 3a and a, so that's the easy part. Now, this time, because I have a negative there and a negative there, I know that the way I'm going to get a negative 4 is going to have to be some combination of a positive and a negative. So, what are the possibilities for, let's consider the possibilities for negative 4. Well, I could have negative 1 and 4. I could have, and then I could just reverse those, 4 and negative 1. I could have 1, negative 4, and I could have negative 4, 1. These are all unique possibilities here because they're getting multiplied by the a and the 3a. And then I could have 2, negative 2, and negative 2, 2. And so those are all 6 unique possibilities. So how can I kind of zero in on things and see what would be best? Well, one thing that I would pretty quickly eliminate would be these two possibilities, because they would involve, if I plug those in and I thought about the outer of FOIL, I would be multiplying 3a by, if I had a 4 here, that'd be plus 12a, and there's no way when I then combine it with negative 1 times a that I can get to there. And if I have a negative 4 here, I'd have a negative here, but once again I'd have negative 12a and then minus a, so that I still can't get near negative 4a. So then let's see if there's any, if I I'm going to eliminate this one, because if I'm getting 3a times a positive 2, so 3a times a positive 2, I'm already going to be at positive 6a, not really a way back to get to negative 4a. So I'm thinking if I multiply 3a, I'm starting to look at the remaining possibilities, 3a times negative 2, that's going to give me negative 6a. I'm really close, put the 2 there, it should work. So you just kind of feel your way to the possibilities. For me, this is the one that kind of occurs to me that should work. If I think about how FOIL works here, and I'm just kind of eliminating possibilities as I go and zeroing in on what would be the ones that work. And just so you can see why this works, 3a times a, 3a squared, 3a times negative 2, negative 6a, plus 2a, there's your negative 4a that you need, and then 2 times negative 2, negative 4, so that's the one that works. And that's called factoring by inspection, factoring by educated guess and check to do those.
This next problem that we're looking at, it has a lot of possibilities for our factors, since you'll notice that 8u could be 8u squared could be 8u and 1u, or it could be 4u and 2u. So that presents a complication here in terms of doing the factoring, because starting out it's not a one possibility, or it could be 4u and 2u. Now we also have the complication of there's lots of factors of negative 15. I could have 15 and negative 1, which means the 15 would go here or here, and the negative 1 would go there or there. Because you have different numbers here and here and here and here and here, that means different possibilities for the O and the I of FOIL to generate this middle term. So you also have negative 115, just reverse those, reverse the position of those, then change the signs the other way and make this negative 15 and 1, or 1 and negative 15. And then you have the possibilities with 3 and 5. 3, negative 5, negative 5, 3, negative 3, 5, and 5, negative 3. Now, the one thing we kind of know though here is that we can probably dismiss all of these because I have 15, if I put 15 even here or here, but especially if I put 15 here, I'm going to have multiplied 4 by 15. I'm going to be all the way up to 60 in that case, and I'll be up to 8 times 15 there. There's no way I'd be able to get back down to an I of FOIL equaling -2. Even if I put the 15 here, that would be 30. 15 times U would be 15U. There's no way I would get down to when I combine the O and the I of FOIL. So I can actually get rid of those. Now, then I need to think of which of these possibilities is it. I'm also thinking that I can eliminate, even with these possibilities, I can eliminate the possibility of having 8 here, once again, because if I multiply it by any version of 3 or 5, I'll be way far away from -2, even when I combine it with the other term, when I put together the O and the I of FOIL. So I'm thinking I can eliminate this one also. So now I'm left with, I've pared down the possibilities quite a bit. I've got 4U times 2U with some combination of one of these. I know it's not going to be a 4U and a -5. That'll be, again, put me too far away, or a 4U times 5. I can eliminate those two. So it's one of these two, and I got to figure out which one it is. As I think this through, it's going to be this one right here, because if I put the -3 there, and I put the +5 here, when I do the FOIL, I've got 4U times 2U, there's your 8U squared. I've got 4U times -3, that's -12U, and then the I of FOIL gets me +10U, and then -15. So that's going to be my answer here, what I have here. That'll be the factoring for that one. Now there are a couple of techniques I can show you that are shortcuts. I really recommend that you use inspection on easier ones, because that'll help you to just get used to the thinking part of FOIL. So, but let me show you this technique. So now this method is called factor by splitting the middle term. And the way it works is, what I do is I multiply 2m squared by -12. And I get, so 2m squared times -12 is -24m squared. Now what I want to do from there is I want to think of, this works much like the technique when you had a lead coefficient of 1, but I want to think of factors of -24m squared that sum to 5m. And if I think about that, that would be 8m and -3m. So those would multiply together to get -24m squared, and they would sum together to get +5m. And what that enables me to do is rewrite 5m as +8m -3m -12. So again, that's still the same expression because I've just rewritten the 5m here, and you'll see why this is. Now I can factor this by grouping. Got to be a little careful here with that subtraction sign. Remember, I can't group with subtraction per se, so I've got to put in a plus sign. I'll group that with -3m -12. And I'll also group in front of that addition sign those first two terms. So this was the importance of that factoring by grouping. So my common factor of 2m squared and 8m is 2m. So I'll factor out a 2m. And then I have m plus 4. And then I will factor out a -3. And that will also leave me with m plus 4. And now you'll notice I have in this term, I have the common binomial of n plus 4. I'll factor that out. And what remains in this term after I factor the m plus 4 out is 2m. When I factor out the m plus 4 there, the minus 3 remains. So I'm left with 2m minus 3, and that's the correct factoring of 2m squared plus 4m minus 12. And that's called factoring by splitting the middle term and grouping. Now when I showed this next method in class, I'm going to put this same example here, 2m squared. This is similar, but the students in class seem to like this technique. This is called the factor by the box technique. And again, I wouldn't recommend doing this on easier ones, but on harder ones it may save you some time. So I make a little box here. Let me move this up well. So what I do is I make a box like so with 4 sections. And just like I did before, I want to multiply 2m squared times negative 12, and I get that same 24, a negative 24m squared. And just like I did before, I want to think of factors of negative 24m squared that sum to positive 5m, and I'm going to have those same terms of 8m, or same factors 8m and negative 3m. All right. Now I'm going to put here's where I'm going to put everything. I'm going to put the 2m squared there. That matters where I put that. And I'm going to put the negative 12. So put this right here and this right here. They have to go there. Now the 8m and the negative 3m doesn't matter where I put those in either spot. So I'll put the 8m there and the negative 3m there. Now what I'm going to do is I'm going to factor horizontally, vertically, vertically. If the first term is positive, then I factor out something positive. If the first term is negative, I factor out a negative. So looking at 2m squared and negative 3m, the common factor there is just m. And looking at 8m minus 12, the common factor is 4. And now looking vertically, I'm going to go 2m squared and 8m. The common factor is 2m. And looking right here, I have negative 3m. Sorry. So looking at this right here, the common factor of negative 3m and negative 12 is negative 3. So now looking up here, this means m plus 4 is a factor, and 2m minus 3 is a factor. So that's called the box technique. That works very, very well. So feel free to use that. That's the same factors I got above. If you want to verify it, it's m times 2m, 2m squared. M times negative 3 is negative 3m, plus 4 times 2m is 8m. There's your 5m. And 4 times negative 3 is negative 12.
Okay, so on this next one I have 5m squared plus 8mn plus 3n. This one is the degree of difficulty added is I have a second variable along for the ride here. But the 5m squared is easy to determine. That's 5m times m. I know I'm going to have everything being addition because I have addition there. So that means that I'm going to need plus signs there, and I know I'm going to need n's here and here to get this n squared and the L of my FOIL. I'm going to have something that generates this 3 though. Possibilities are 3 and 1 and 1 and 3. There really aren't many possibilities. Pretty sure it's not this one because that would mean that the 3 is right there, and that would mean it gets multiplied by the 5m and the 3n, but this is already below that, so that can't be it. So let me erase that. So this other one's got to be it, and I'm going to say 3, and I could put a 1 there, but that really isn't necessary. Let's just call this 5m plus 3n times m plus n. And just, that's the correct factoring, but just to verify, since this one's a little busier, you know, again, this is an unnecessary step, but just to show you that this works, if I go 5m times m, that's 5m squared, and if I go 5m times n, that's plus 5n, 5mn, and then if I go 3n times m, that's plus 3mn, and then I do 3n times n plus 3n squared. Here's your 8mn right there. That's 5m squared plus 8mn plus 3n squared. Back where I started, that's what I want. But this is the correct factoring right here. Okay, so let's work on this next one. This next one, you're going to have to do a little rearranging to start. You don't want to have, you want to have these in order of descending hour of the powers of one of the variables. So let's go put the a squared term first. 20a squared, and then plus 3ab, and then the term without any a last. In terms of generating the 20a squared, I could get that by 20 and 1, or 10 and 2, or 4 and 5. But I'm pretty sure it's not going to involve the 20 because I've got this really low coefficient of 3 there. So if I have 20 involved, it's going to be very tough for me to get back down to 3ab. Same with the 10, quite frankly. So I'm thinking it's something to do with the 4 and the 5. So, but I'll tell you what. Let's do this one just so I've shown you one more time how to factor by splitting the middle term. Let's take, we're going to multiply the 20 by the negative 2. So 20 times negative 2 equals negative 40. So I want factors of negative 40 that sum to the coefficient of the middle term of this 3. So that would be, so sum to 3, so that would be 8 and negative 5. So I'm going to write 20, well, let's do it in blue, get my original scheme here. 20a squared plus 8ab plus, or that's going to be minus 5ab minus 2b squared. So I'm going to sneak an addition sign in here, and I'm going to group here with that negative on the inside of the parentheses. Now I need, let's factor these two terms. This common factor there is 4a. That's going to leave me with 5a plus 2b. And I'm going to factor out in these next two terms negative b, or minus b. And I'm left with 5a plus 2b. I've got a common binomial of 5a plus 2b, and I'll factor that out. And I'll be left with 4a minus b, and that's my correct factoring that would multiply back together to get this right here. These next two are what we want to always be on the watch for, what we call trinomial squares. And trinomial squares are really just perfect square trinomials. That means they would just like a perfect square factors to something times itself. That's what a trinomial square would do. And you can recognize those by noticing that's a perfect square. I really didn't want to circle that. Alright, so you can recognize that as a perfect square, and that's a perfect square. And if 2 times, so the square root, so here's how you know if you've got it right. The square root of 9x squared is 3x. The square root of 1 is 1, and if you multiply that by 2 and that gets the middle term, then you know you've got what's called a trinomial square, and that the factoring of this would be 3x plus 1 times itself, so squared. Because remember, this would follow the a squared plus 2ab plus b squared rule. So if you followed this right here, you would see when you squared 3x plus 1, you would get this, so you know you've got it right. So one more of those. This one's also a trinomial square. Its only difference is it has a negative middle term. So notice that's a perfect square, 25x squared. So is that. And by the way, a trinomial square always has to have an addition sign before the third term or the constant term. And so you have, so let's look at so the square root of 25x squared is 5x, square root of 2 is 2, the square root of 4 is 2. And then if I multiply that by 2, do I get 20x? And it's okay to get a positive there, because we're going to realize that when we factor this, we're going to need to have a negative between the two terms of the binomial that it factors to. So this will be 5x minus 2, the quantity squared, and that minus right there, when that follows the, again, this follows the a minus b squared pattern. So that would be a squared minus 2ab plus b squared. And if you did that to check this by following this pattern with this, you would end up with this, and you know the factoring is correct. So that is the end of the lesson.